Hello and welcome to another tutorial. We're looking at the instance of operator in Java, and this is basically also a binary operator. And what this works, it compares the left hand side of the instance of operator and examines it and sees if it's a instance of the right hand side. And this could be the exact match, which means the same type, or a subclass, right? Because any subclass of a particular class is also an instance of that class. So the instance of operator compares an object to a specific type. You can use it to test if an object is an instance of a class, an instance of a subclass, or an instance of a class that implements a particular interface. So instance of is not just for comparing classes. You can see if a class is an instance of an interface. And the reason this works, or this is meaningful, because a class can implement multiple interfaces, and therefore you cannot see, basically using the instance of operator, you can check if that class implements that particular interface. Now obviously the other way is Java reflection, and behind the scenes instance of method actually uses some sort of reflection, because this instance of is something that happens at runtime. So at runtime, JVM through the JVM you can examine the type of an object. The following program instance of demo, and remember the reason that we need this kind of instance of operation, so the Java provides this because of polymorphism. So when you if you don't have polymorphism, or if you don't have this instance of, then you want to basically overload the method for every particular class, and sometimes all you provide as a public API is an interface, and then you write a method that takes that interface type and does some stuff with it. Then if somebody implements that interface through a class and passes that class to an interface, then you have to be careful what happens, right? The following program instance of demo defines a parent class named parent, a simple interface named myInterface, and a child class named child that inherits from the parent and implements the interface. So if you look at the example here, you see we have a parent class, it's empty, it doesn't really have any body. A class child that extends the parent. Remember, every class can only extend one class. You cannot have multiple inheritance, but you can implement many interfaces. And then interface myInterface. And remember, in Java, because there is no global scope, the only scope that is defined is the scope of classes and interfaces. Therefore, the order, the way you write this don't matter. You don't need to define the interface before this child class so that you can implement it. Because every one of these class interface, these get compiled to a separate class file. And at runtime, when the JVM sees the type, it tries to load a class file that associates with that particular class or interface, right? If we cannot find it, obviously JVM throws a runtime exception like class not found error or class def error, something like that. So the order doesn't matter because there is no global scope. Unlike C++, in Java, you don't need to do prototyping because these things get compiled to class files, right? Separate files. And then at runtime, JVM finds them and load them whenever it's necessary to use the classes or interfaces. So parent, child, obj1, which is a parent instance of parent, that's true. This is the exact match for type. Also remember that any class, because it implicitly inherits from object class, so every class is also a subtype of object. So if you say obj1 instance of the object class, it always returns true. obj1, which is the parent instance of child, no, this is false, right? So this is false. And then obj1 instance of myInterface, it's false because parent doesn't implement any interface. obj2 instance of parent, this is true. obj2 instance of child, this is true, and this is the exact match. obj2 instance of myInterface, true, because it implements the interface. So basically at runtime, one of the main use cases of instance of, you want to see if a class implements an interface. So let's and obviously this is the output. When using instance of operator, keep in mind that null is not an instance of anything. And remember, a object reference can be null, and they could make this a compilation error, so that if one of your variables is null, for example, on the left hand side or right hand side, the compiler could give a compilation error, but it doesn't work like that, and they just defer it to runtime. Remember, instance of is an operator for runtime. At runtime, you want to check the left and right. So the Java compiler doesn't check if any of these references is null at compile time. So let's create a new class, instance of operator, and then let's have a main method. All right, so let's create a method, public static void test1. All right, and I'm going to run test1 here. So what are we going to do in test1? So we're going to say that int x1 is 5, int x2 is 10. Can we use instance of for primitives? So let's see, x1, let's say var, or let's do a sysout x1 instance of int, instance of, remember instance of is one word, int, for example. Now this doesn't work. If you look at the compiler error, it says that incompatible conditional operands type int and int. So you cannot use these for primitives. What about the integer class? This also doesn't work, incompatible conditional. So if I say integer class, now this works, right? So instance of only works for classes. It doesn't work for primitive types. x1 instance of integer, that's true. What about short from Java lang? And incompatible condition operands short and integer. So at the moment this doesn't work. You cannot compare a short with an integer. We can say short, which is a class, instance of object. This works, and this will return true. Anything is an instance of the object, true. But for example, if I use an interface comparable of short, for example, so how does this work? This is true, because if you look at the short class, it implements the comparable and clonable, right? So we can examine that if this variable, which is of particular type, remember a statically typed language means any variable has some type, an instance of for non-primitive types, right? And then you can check, for example, if this short class, a variable of type short, whether it implements an interface called comparable of short. What about comparable of integer? And now this gives us a compilation error. Type short cannot be safely cast to comparable of integer. So basically what happens at runtime for this instance of, JVM tries to typecast the variable and see if it's a valid cast or not. So if you want to see this, let's go back to comparable of short. And then let's look at the bytecode. So I'm going to comment this one out, and let's look at the bytecode, that what actually happens in the bytecode for the instance of class or instance of binary operator. So let's look at this. All right, let's look at the test1 here. So we load the constant 5. Obviously this is an integer literal, and then we load it and then push it to x1, invoke a static. So this is a class, and we know that if you assign a primitive to a class, wrapper class, it uses the static factory method value of, which is in the short int. All the wrapper classes have this primitive, basically this static factory method value of. So it translates this assignment operator to a call to the value of method, and we saw that that's the same way the operator overloading plugin works in Eclipse for overloading the assignment operator for your classes. And then a store 0, a store means load a variable that is a pointer to an object or a reference to an object, and x1 is stored in the index 0 of the stack. The reason is that this is a static method, so we don't have this pointer stored in the stacks of the method, stored in the stack of the method. Each method gets a stack, right? And then basically we have to and then it pushes variable stuff into the stack, and once we return from a method, everything from that stack frame is popped, right? The stack frame is destroyed. All right, so let's see. So these 3 lines of bytecode is for the first line here. What about the second line? Maybe we just extract this. So boolean x2, this one, and then we just print x2, right? Now we extract it. Remember, instance of returns true false, so the return type is boolean. And then in order to calculate this is a binary operator. The left hand side is evaluated first, so we have to load this x1 again, which is a pointer, and then instance of, we have an exact bytecode for instance of comparable. Remember that generics don't mean anything in bytecode. In bytecode there is no such thing as a generic because of type erasure, right? Because of type erasure. And if you recall my previous lectures, the way generics works is that at compile time, the compiler deduces the basically the most generic type that it can assume for this class that has this parameter type. So in this case, it's short. So it says a check calls the instance of with comparable. And remember, instance of checks the last value that is on the stack, which is x1, and it checks the instance of with comparable. And then I store 1. It stores an integer 1 in the x2 variable, which means the result is boolean true, right? Remember, in bytecode, I store 1. So let me just copy this line. I store 1 means save boolean value true in x2 variable, right? Integer, store an integer of value 1 in this variable x2, and then it gets a static field out, and then calls a virtual method, which is print line. It's a non-static method, which means invoke virtual, print line, and then it prints a boolean, right? So what happens here, we have an exact bytecode for, so we have a bytecode instruction just for the instance of method, right? Now, what's the other way to this kind of test? Obviously, we can check using Java Reflection API. I don't recommend that, but Java Reflection API is more powerful. And the way it works is that basically you have to access the meta information. And let's see. So I'm going to remove these, right? So we get the x1, and we say that a class of anything class is x1 get class, right? And this class has the meta information of this variable, right? So for example, we can do a sysout on class, and what happens here is that if we run this, we get so let's run test 2 here. So let me also close this bytecode view, and then if you run this, it says class Java lang short. It gives you the fully qualified name of the class, right? And then what can we do with this class? Get interfaces, get annotated interface, get generic interface, get interfaces. Let's extract a variable, class array interfaces. For interface, we cannot use interface because it's a reserved keyword. For interface in or basically, let's write this for var interface in interfaces. We're going to use a sysout on the we're going to do a sysout on the interface. So let's see what information that we get. So we see that this variable, which is of type short, we access its meta information, and then we get an array of interfaces. Remember, this is not an interface, this is an array of classes, which means these interfaces are actually meta information. And we see that there are 2 interfaces that this variable implements, comparable and clonable. And again, there is no mention of generic type, what kind of comparable or clonable, but that's because there is no such thing as generic in bytecode. And then if we want to see if x1 implements a particular interface, we can say basically we can do a manual check. So x1 So basically we get the class. If you look at the methods, get field, get fields, get generic, get interfaces, there are a lot of get methods that you can use to interrogate your class, the meta information. And then we can say is annotation present, is array, is instance, is interface. You want to see that if this variable is actually an interface or not. Sysout is interface, and this returns false because short is not is not an interface. Remember that it implements an interface, but it's not an interface type itself. It's a class, right? So you can say sysout class, for example, is local class, is member class, is local class, is anonymous class, for example. These are the kinds of meta information that you can interrogate. Now, if you want to see if this x1 variable basically implements a particular interface like comparable, what you do is that you say boolean, basically you want to check that if a particular one of these interfaces matches the comparable class, the meta information of the comparable class. So we can do this. We can write a for loop, and we can say if this interface, let's do a var a equals inf equals, remember if is a class, so we can say comparable dot class, right? And then let's do a sysout a. Let's see what we get here. And we get so let's see, as I'm going to create a %s equals %s, and then one arrow %s, for example, and then formatted, we're going to inf, and then comparable class, for example, and then a. Let's see if this works. Let's run this. So we're getting two things here. So comparable in this interface basically let's see, we have to actually use this class, not the interface. So this class with the inf, right? So we want to use the meta information of the, let's see how this works. So we get false, false, and so we went through the and then Java language. So this class is Java lang short, and we have the interfaces that this, okay, so we have to do this inf equals comparable dot class. Yeah, we have to do this actually. Yeah, so all the interfaces that this class implements, and we want to compare these with so we're going to say that interface compared with the comparable class, the meta information of the comparable class, and let's see. So there are two interfaces that this class implements. One is comparable, so true, and note that we're not doing any generic here, right? So you don't say, can we say comparable of short, for example, dot class? This doesn't work. When you have a generic type, you cannot say, you cannot use the parameterized type for the class. You have to just use the class itself. That's because in the bytecode level, there is no generic type, right? They will be erased. So if I run this, as you can see, the first one returns true, which means my class has a couple of interfaces that it implements, and one of them is comparable class. So if we didn't have this instance of method, we have to manually do a for loop on all the interfaces that this class implements. Now let's look at one more thing, get interfaces, get generic interfaces. So what about this one? So let's see. And then interfaces. Now we're looking at the generic interfaces. Okay, let's remove this line. And as you can see, we have a comparable offshore. Now if you get generic interfaces, now it actually shows the type of the comparable class. And now what it does is that when we do this comparison, comparable.class, it returns false, because we are comparing the comparable of short versus comparable, which is a raw generic, and now it's false, right? So if you want to be more specific about what interfaces is parameterized, then you can use the get generic interfaces. And again, I don't want to go into the details of the Java reflection. The idea here was that instance of method, you have to specify the generic type. You cannot say, I mean, you can say comparable here, but it's a raw type. So if I run test one again, now I'm comparing this short, see if the instance of a raw generic interface is comparable, and it returns true. But if obviously I cannot say integer, for example, here. If I say this, then I get a compilation error. So at compile time, it already knows that it cannot, these types are not compatible. If I use a wildcard here, let's see, comparable of anything, it returns true. And if I don't use a type here, then it still works, right? So you don't need to use a generic type, but it's better to be more specific, right? You can say comparable of short, true, right? And then we can also basically interrogate the meta information of the class for this variable of type short, either interrogate all the interfaces without the generic type, or also include the generic types. Let's run test 2 again. And you see that we have two interfaces. One of them is generic, comparable of short. Now what about, now we're getting false here. How do we get basically how do we get the compare these interfaces with a generic type? So let's see, comparable of short, and then let me see if I can see if that class works on this one. No, it doesn't work. What we can do is say that comparable dot class, and then this returns a let's see what this returns. I think it returns a class of comparable, without any raw, basically any generic type. Desired as, let's see if we can get the generic to generic string, get generic interface, get generic, so it has a get generic interfaces, and it returns an array. So if we get index 0, index, so this is out of bound. Why? Let's see, let's run this again. It has an array of objects with one element, so it should give us index 0. Yeah, this one, I guess the second one doesn't work because clonable is not a generic interface. So we can use this, and then we're going to we can do, for example, try. and say var a is this, else we're going to copy this and say a is just a class, right? Boolean a, for example, we're going to set this to false. So what we can do here, if a class has generics, we're going to let's cache these. Try catch. We can use try catch, something like that. Or finally, I think this also works here. Or we can use try and then catch something, exception. If some exception occurs, we're going to say that compare it with a non-generic type, right? So let's see how this is going to work. So Java lang comparable short and comparable. Okay, so we are let's do this. Let's also put this here, and then we're going to get this and print it here. So if an interface is generic, and we want to really compare our interfaces based on their generic type at runtime, we can also do this. And what we're getting here is we're getting the interface, and then I guess we're not doing this, but I'll leave it to you as an exercise to figure out how to do it with Java Reflection. It's a bit more complicated, especially when it comes to generics, right? But the instance of operator is still okay. You can use it either with the raw type or with basically the generic type. And my recommendation is that you use the generic type, for example, comparable of short, for example, right? So I hope you enjoyed this lecture and now have a good understanding of how this instance of method works, and I'll see you in the next one.